Hi everyone, welcome back to my channel. Today's topic is context relevance. Context refers to a set of tokens that is included when sampling for a large language model. So we are going to see if our retriever found it, did it find the right thing? Retrieval does not just stop at the search step. First, we learned about hit rate and then MRR. These are the two metrics that we've uh, used to understand what's happening at the retrieval stage. Now we're going to learn about context relevance. So we usually stop at did we find the right document? So that is suggested by the hit rate. But after retrieval, the top K chunks that are found by the model are stitched together into a single context window. And this context is then given to the LLM along with the query to give us an answer. That would be the part of the generation step. So the context that we are passing to the model, we are going to check, did we retrieve something relevant? Out of everything that we gave to the LLM, how much was actually used to answer the question? So similarity is not same as relevance. So similar vocabulary may not always result in the answer containing what we want. Say the answer to the question does not really contain the same words as the question itself. That's the nature of how it is. So a question about, say, a chunk is retrieved about premium gold membership. So it can be similar to return windows, but it does not certainly answer the question about gold membership box. To talk about the formula for context relevance is sentences relevant to the query by total sentences in the context. So how many sentences were actually right and that were relevant to the query, which would actually answer the question, by how total number of sentences that we have. Again, the range is from 0 to 1. Higher the score, that is better. So if it's 0.4, say suppose, then 60% of what we gave to the LLM was just pure noise and we had to bear the cost of it. So context costs money. Whatever we pass the model, we're just wasting more money, and that doesn't really add any value. It degrades accuracy. We are giving it noise, so it dilutes the signal. A right answer gets buried somewhere in under irrelevant context. So the question is, what is the return window for premium gold members? The answer to which that is relevant is premium gold return window is 60 days and standard return window is 30 days. And other things that were retrieved in the top K, those are not relevant at all. So ideally, these shouldn't really pass in the context window. So if our context relevance is 0.4, only 2 chunks are actually relevant to the query and others were not relevant. So we don't want the right answer to be buried under the noise. And this can also lead to hallucination. The model can consider the other chunks as well and may result in incorrect answering. So low context relevance is a retrieval diagnosis, not a generation one. So it's a reflection of how the retrieval process all in all was. So vocabulary matching can only be a surface level thing, not the actual intent. We can also find that the chunks might be too large. That's why we are getting extra information that is irrelevant. Or the embedding that was done itself was not right. It did not capture the domain-specific relevance accurately. They did not understand the caveats of how the embedding was supposed to be done. If we look at hit rate versus context relevance, hit rate only says whether the right document was in the results or not. But it does not say how much noise it comes with. So that is something we are going to check with context relevance. So ideally 0.8 or above is good. 0.5 to 0.8 suggests that we have to investigate the chunking strategy and see how we can improve the retrieval process. If it's below 0.5, then it's LLM will always fight with itself, and that's really not useful. That's about context relevance. In the future videos, we'll learn more about context and context engineering. So please look forward to that. Thank you so much for watching my video. Please subscribe to my channel and bye.